Okay, well, welcome to everyone that's joined. Thank you for taking the time out to spend a few minutes with us to learn about why digitalization doesn't have to cost $1 million. So I'm going to take you through some examples today of things that we've done for our customers where they've delivered a lot of value and they haven't cost $1 million, far from it. And in fact, you could probably implement all three of the things I'll show you for less than $1 million. Now, of course, there are some caveats on the cost in that this is estimates. These are ballpark figures, and it doesn't include long-term support costs. But nonetheless, the point is to illustrate the point that you don't need to spend a lot of money to start getting value on digitalization. So I'm going to talk about the low-hanging fruit. I'm going to talk about where it is and what it is. We'll give 3 examples and then there's some time for questions. Now you don't need to wait until the end for questions. Please just jump in. You can type them in the chat. My panelists with me will help moderate those and feed them through. So before we get in, I want to just talk about 2 really important tenets or ideas that we believe in and have experienced through our 13 years of delivering digital projects for customers. The first one is that to deliver value, you need to take and act on decisions faster or better than you could before. If you don't get to the point where you've taken a decision and acted on it, you haven't got the value out at the other end yet. All you've done is played around with a part of the overall workflow. The second thing is that digital initiatives must be delivered while the asset is still operating. What does this mean? Well, the obvious one is you can't just turn everything off and start with a blank sheet of paper and redesign it. You have to come up with things that can be put in place while the asset maintains its production and while everyone goes about their daily work. That means in most cases, it has to be step by step. So you're looking for things that people can switch to without too much difficulty. So you could maybe implement a part of it and it starts delivering value straight away. And where possible, you don't change what people are already doing, or rather you just make it easier for them to carry on doing their daily work. So the good news is that there is a lot of low-hanging fruit. So where is that fruit? Well, if I was to put the 4 ways that you can save cost or get value from digitalization, the first is reducing your cost. You can avoid losses or you can reduce waste. The other side of it is that you can get more income. So you can produce more oil or you can find more oil. Going from bottom to top in that square, the cost of implementing those generally goes up. So it's cheaper to reduce waste than it is to avoid losses. But both of those will only increase your margin, they'll reduce your cost side. You don't necessarily produce more oil, although obviously avoiding losses, your yearly production will be up a bit. The other side, producing more, if you can find a way to open up the taps a little bit, get more through your system, that gets you more overall income. And that's generally cheaper than finding more oil in the first place. Okay, so that means the cheapest things to implement are going to be in the bottom left corner to start with, reducing waste. So here's a chart I've put together of cumulative value over effort to implement. So the lowest thing you can do is reducing the overhead of communicating priorities with staff. It's something you absolutely have to do all the time, and the better aligned people are, the better they'll work and the less waste there'll be. Right, it's going up the curve. There's various things like eliminating waste, finding information, eliminating low value manual work, reducing the time needed to understand the status, then having trusted alerting. So when you get an alert, you can act on it, improving the coordination of activities, then into better planning, better predictability, and finally, really high level stuff like, say, remote operation and reduced manning. As you move from left to right, the cost of implementing those goes up. It's not exactly to scale, but as a rough estimate, the examples I'm going to show you are all less than $1 million. They're in the sort of 20K to 500K range. The last example could cost a bit more than that, though. They also tend to flow from using existing information and work processes. And as you move to the right, you start generating new information, and then you start changing work processes. So the cheapest things to implement are where you keep existing information with existing work processes, and you just make them more efficient. Okay, so here's the three examples I'd like to talk about. First one is at the lowest level, simple communication of priorities. This is something where we've done, you have an online slideshow of information that's published on a single URL that can go on communal screens or anyone can log into. This is using our screen presenter functionality, and it lets you share information immediately without having to email it. The content can be made from PowerPoint, so it's not complicated for anyone to use. Most people are familiar with PowerPoint and probably already using it to communicate stuff. Because it's on a web link, it's much easier to put on communal screens. You don't have to have someone walking around or remotely logging into machines, loading on a PowerPoint and playing it. The next example I want to talk about is the quick access to information. So this is adding a semantic layer, a data model across the information in existing systems so that it can be searched and found easily. And the last example is the improved prioritization of activities. This is an example where we reduced the maintenance backlog on safety critical equipment by 90% within 3 weeks of implementing this software. This allows people to see the link between maintenance and the health of safety barriers on the platform. So it was all existing information, but this allowed an understanding of health based on that, which was otherwise very hard to see. This is actually the same example, but this has some figures on the cost benefits of it. This was the same software, but on another asset. The estimated savings were somewhere in the range of $250,000 to $850,000 a year from productivity alone. There was actually 8 areas of value identified, including just better job satisfaction, because people were more confident in their ability to deliver a safe platform. There was also improved brand value to the company because they were able to demonstrate that they were doing things better than their competitors. So, okay, first example, reducing the overhead of communicating priorities with all staff. This, I'm going to demo our screen presenter product. The cost of implementing this is between $15,000 and $25,000. Most of that is talking with the internal IT team and getting it set up. It's a very simple program. It's really easy to use. So let's take a look at it. So here it is running on a URL. And what we have is just a series of screens that are circulating through. This is the list of things, and it can be, at the moment we're on this it's a live website, so it's a text file with a link in it, and it just opens that website and plays it. We also have images that are static images, and these could be generated from a PowerPoint. So you export a PowerPoint as images into a folder, and then it just cycles through them. What that means you can do is make like a mashup of different information from different sources. It might be helicopter flights website, it might be the exchange rate, it could be a report on health and safety from a PowerPoint. They all just go in a folder and it works through them. And if you need to update them, it picks it up instantly. As soon as it's changed, it's there. Okay. Remember, if you do have any questions on these, please just put them in the Q&A section and we'll get to them at the end. So the next thing I want to talk about is eliminating wasted time from finding information. So this is a little higher on the cost of implementation, but also the value is higher as well. Cost of implementing this is somewhere in the range of 50 to 250K, depending on the size of the data model you want to build and the state of the information underneath. This, I'm going to demo our semantic search. We use 2 open source technologies to do this. We use Elasticsearch and Neo4j. This lets us keep the cost down because these are open source licenses, and also their industrial platforms are very well supported and they're well known within the industry. So here, I've already done a search. We search for something, and it brings up the list of, it's just a text search across our search index in Elastic. Anything that's related to that, it would find. We could also say search for a vessel, say some vessels, and anything with that text string in would come up here. If we want to find the related information, we click on it and it brings up our common menu. This brings up all the information that we know about in other systems. So here it might be a real-time system and the information's all live and interactive. Or you might have documents. These are just example documents, so they're dummies, but I'll just show you opening one. So this could be a link to the document management system, for example, ProArch or Documentum, SharePoint, Aviva, and it will just open the document from that system. So that makes it super easy for people to find related information. You can also navigate through the model, and maybe you have some maintenance info in the maintenance system as well. It could be SAP or Workmate. So again, very easy to use, but it's just reducing the wasted time of people to find information. This is some other examples from search results showing the common menu and the different kind of things that you can have. I think one of the most powerful features of this is actually the linked documents. Finding the latest or correct document related to stuff can be very time consuming. Okay, the last example I want to talk about then is a higher up on the curve. This is improved coordination of activities and prioritization. This costs somewhere between $250,000 to $750,000 to implement. Again, the lower end is for simpler models with good data, where the source data is in a good state. The upper end is where there's maybe a lot of cleanup required, or it's a very complicated or involved calculation. This is an example using our safety barrier health software. This is implemented on 2 assets in the Norwegian continental shelf. It integrates with multiple source systems, from maintenance to HSEQ, risk assessments, device alerts, people on board, and it pulls in the information and runs rules over them to produce status at every level. So what do I mean by every level? Well, you can cut the information and aggregate status by area, by asset, by performance standard, by system, by major accident hazard, and others like barrier function element. It does this by having a model of the barrier system. It enables you to calculate status and aggregate it up through the model, and then cut the model like at any layer to see. Let's switch to a quick demo of that. So this is the overview page of the barrier panel, and it gives you a high-level overview of the status, the health of all the barriers in these different areas. And if you hover over one, it gives you the breakdown. If you wanted to click on any status, it gives you the details of what makes up that status. So this is helping engineers go from the high level view back down to the low level, right down into the source data. We have a summary of the information by priority. So invalid in this case means that there's some information has been put in at the low level that doesn't make sense against the rules. And again, people can go in there and find out what the problem is. So in this case, we've got an issue where we've got the risk handling has expired, and the users need to go in and re-look at the risk assessment there. Moving from left to right, then the most critical is where we've got a red alert with no compensating measures applied. So this lets people, draws the attention to the one, in this case, piece of equipment that has a high risk or has a high impairment and has not yet been assessed, and any risk handling or compensating measures put in place, and it takes the user right into the source system so that they can fix that. Then going across from left to right, we've got ones where there is a risk, but it's been handled, it's been risk assessed. Others where there's compensating measures in place, and others where it's been assessed and there's no risk. So for example, here we could go and look in. So this does have a suppression in place, but it's been reviewed and said actually we can accept this for now. It also gives people a view of the severity of the impairments in an area. So in this case, we only have one red area, but if you had several red areas, you could see which was more red than the other. And it's all interactive so that the users can drill down straight away and see where the holes in the Swiss cheese are and what's causing those holes as well. The information can be cut by area, which we've just seen, or it can be viewed by system or performance standard. This is important because, as you can see here, we've got 2 yellow performance standards, but we've only got one yellow area. So when we cut the information in another way by performance standard, actually our non-compliance looks different than if we just aggregated it in one direction. And also, people like discipline responsible engineers may have responsibility for a performance standard. So what you might find is that at the area level, everything's okay, but at the performance standard level, there's an impairment because, say, something like gas detectors, there's a few gas detectors out in each area, not enough in any area to cause a problem, but overall, you've got maybe 5% of your gas detectors out, and that would show up then at the performance standard layer. There's then tools that allow people to investigate the data further, to make search and filter across all the different signals and find groups or sets of them that they're interested in. There's various KPIs that need to be complied with, for example, number of active inhibits and things over time, summaries of work orders in the different areas, and then some trends of status. This looks like it's got really bad, but that's because we've reset the demo data for these purposes. But ideally, you would see that trend going down or at least staying low. And it gives people a feeling of not just what's the status now, but have we consistently been performing in a good way? There's then links to useful documents or related documents and tools for maintaining the system and updating the rules and things in the background. Okay, that's good. We've made good time. We've still got some time for questions at the end. So has anyone got any questions on what they've seen today? And I can't see the Q&A panel, so I need to ask my panelists to jump in here. Let me see if I can get the panel up. Q&A, there we go.
There's nothing just yet.
Murray, maybe you can elaborate on the importance of using industry sort of standard backend tools like Neo4j and Elastic.
Yes, absolutely. Okay, so let's go back up to that slide. So what we're trying to do is make best use of industry tools rather than rewriting them. When we built the system, we looked at a number of different open source options. Search, Elasticsearch was a market leader really 5 years ago when we were putting it in, and it's continued to be in that way. We also had to differentiate between searching for something and storing the data model. Elasticsearch is not a good tool for storing a data model because of the way you have to structure everything, and it's documents-based structure. But it is extremely good for text search. So that's why we've used 2 different tools. Neo4j is an excellent graph database. Its performance is very, very good. It does have built-in search, but it doesn't do search as well as Elastic. So we use the 2. We also use some other open source components like InfluxDB as a time series database. So that's instead of, say, OSI Pi or IP21, Influx is open source, so it's free. Or you can buy enterprise licenses for it. Its performance is very, very good. It doesn't have all the same features built in as say Pi or IP21, but we're able to code around those in our interface. So it lets us keep the cost down for deployment, and it also means that we're not writing custom code to do stuff that's done elsewhere. And so if we deploy our systems for a customer, if anything ever happened to us, the data is still in open source systems. So for example, the data model is in Neo4j, so it's always going to be accessible. It's not some in-house proprietary code.
We have a question from Antonio here. Screen presenter, can you split the message to the different areas of the business? For example, sometimes an information for offshore people is more focused than, let's say, warehouse.
Yes, absolutely. So all you do is just create several different URLs with a different folder, and then information that's just relevant to one channel, if you like, you just put in that folder. So you could have as many folders as you like and as many different URLs. And so we could call it like channels almost. You just create a channel then for offshore.
Yeah.
Yeah.
Okay.
Good question.
He says, example for hours of the day, split it to departments, 8 hours to share company news, 12 hours. Thanks. Yeah, I think, yeah, different channels for different audiences.
Oh, yeah. Okay. Yes. So what you're talking about is almost a programming, then having actually a schedule of information. So yes, now funnily enough, we had a different product that did this years ago, where you could put like a schedule for the day of what was to be done when. Screen Presenter doesn't currently do that, but we have the code from our previous product that we could implement that. It's not too difficult to do. So yeah, then you could create schedule of programs for each of your channels. It's a bit like a TV then actually. So yeah.
Murray, there's a couple in chat. So firstly from Lucas, it says, thanks for sharing info about the budget of such projects. That's interesting. What about time from the decision we want to use Eigen software to the moment when the company is able to use it? How much time takes to deploy one of your solutions to a business which is interested in using it? Okay,
great question. So our systems are all cloud-based, so the actual deployment of the software doesn't take long. It's a matter of a few button clicks once it's been agreed where we'll deploy to, and so it's initially the most time-consuming thing is agreeing with the business where we will deploy and how it will be managed and any security around it. That's basically the time limiting factor there. Then to set it up, Screen Presenter just takes a couple of hours. It's very, very simple. We just need to create a folder and put some content in it and assign a URL. The search, that can take between 3 weeks and maybe 9 months, depending on how much information you want to integrate. The best way to do that one is to go step by step and choose a small subset of information and get it in, say, take the master equipment list, the engineering numbering spec and the document list, and run some scripts over it and get the basics in. Then maybe add in some known models like the well models in there. And I don't mean the reservoir model, I just mean how the equipment is linked in the wells, slots, templates, flow lines, all of that into separators. Then you can add other stuff like barriers later. So you could have something working within a month on search, and then you could just continue adding to it for another 9 months, say, to depending on how much information you've got. Then safety barriers. This takes a bit longer. You need to have a data model behind the scenes for that. So you've got to start by building that and having at least the equipment in there that you need to monitor as part of the barrier model. Realistically, that's between 3 and 6 months to set up, and then probably another 3 months to validate it. So you're probably looking at 9 months for a project to go from nothing to having a barrier panel in place in there. We have a fixed cost deployment model for that. So we're now moving to a fixed license fee, and as part of that, we'll include the initial setup of the barrier system, and then the license just continues, and that covers the support and the license fee after that. Okay, so I hope that answers the question. All of them you're looking at less than a year.
Amazing. Lucas, thank you so much for your question. And we do have another one from Christoph. Murray, many thanks for the presentation. Can you give some more information on your approach for starting digitalization projects with new clients? Basically, how is the journey planned, and are you also involved with identification and ideation phases, i.e. workshops, etc.?
Oh, great question. Okay, so yes, absolutely. That we've learned a lot in the last 13 years, and it's very important to start with something small and go step by step. And you're absolutely right about the initial discovery phase and ideation. We, as much as possible, we follow design thinking now. We actually follow a bit of a cut down version of it. But the key is to go through the process of getting everyone in the room and defining what it is that needs to be done, then going into rapidly prototyping something and getting something working, reviewing that, deciding if it does solve the problem, and then putting it into play. Now, our software is productized, so we don't need to prototype the code. What we're talking about here is getting connectivity to the real data and trying to do something with it, trying to achieve a result. This is exactly what we did with Wintershall. We went through a pilot phase where we connected to their real systems and we built some real stuff that they then used with a small subset of people. The reason for doing that is because it's only when you connect to the real data that you find out what the real issues are, and things like inconsistencies in the data are the things that catch you out. So you've got to flush those out as soon as possible, and then you get something working and into use, and then you just keep iterating. So once the system's in, like we're doing with Wintershall there, it's great to have an agile team together that can then work in sprints with the users to continue to deliver stuff that makes their lives better. Because as people get into using a system like Ingenuity, more and more ideas come up, and people start to think in the new way of things working. It's a bit like mobile phones. I know this has been used a lot, but the whole idea of apps, people didn't think in apps before, but once the phone came along and then the idea of apps was available, all sorts of new thinking comes along as, well, what could an app be? And the same happens with digitalization. People are used to working in an old way, like with spreadsheets and PowerPoints and things. And it's hard for them to think of how the new way will be until they experience it. And I know that the joke was said by Henry Ford when he made the car. If I'd have asked what people wanted, they'd have said a faster horse. But when people see the car, then they realize, oh, this is what it can do. So then having the ability to respond quickly to people's needs and deliver more and more and more is really, really valuable. If you were to go straight in with a project like safety barriers, then you'd follow a bit more of a structured process, because then needs to be the discovery phase where you get all the information for the data model, rules processing, systems you're going to connect to, and so there's a project structure to go through with that. So I guess to some extent the approach then depends on exactly what's looking to be achieved, but that's no surprise, is it? People always say that in response to stuff. But a great question, and happy to take that offline. If anyone wants to talk more about that, then please do contact me afterwards. So I hope I answered that question. Sorry if I rambled a bit. I think we've got time for maybe one more. Is there anything?
So there's nothing else in Q&A or chat.
Okay, well, that's
great, perfect. Thanks, and a smiley face from Christoph.
Okay. Excellent. Well, I think that's actually perfect timing. I just see we've turned 10. So fantastic. Thanks very much, everyone, for attending. I hope that was useful for you. And if you've got any questions or things I haven't covered, please do contact me directly, and I'll do my best to get back to you. Thanks very much.